Hello and welcome back to Advent of Code 2023, day 13, lucky day 13. Hello DIJ, since when do you stream at 11 p.m.? Well, it's coming up to 1 p.m. It was always my plan to stream like on the dot the moment the problem releases. But that plan failed every day this month so far. So I have not been. This is the closest I've been on time. Closest I've been to on time. Something like 50 minutes late. But better than 4 to 5 hours late. So so yeah, maybe one of these days I'll actually be able to start on the dot. We'll see. I am in a different room now, so I think the lighting is better. You can actually see my eyes. They're still quite shadowy, but better. Sorry. Let's hope the Wi-Fi holds out here. I think it seems to be stable so far. Lucky 13 cannot be worse than 12. Yeah, I mean, here in Southeast Asia, they not only replace all the floor number 13s with 12A, but all the floors with the number 4 in them also are replaced. So it's to appease both the Americans and the Chinese, because Chinese don't like to see the number 4, because that's like death. So when you so then you end up with like floor 10, floor 11, floor 12, floor 12A, floor 12B. I don't remember how it works. Basically, you see a whole array of letters and numbers appearing in the elevator floors, and it's not even clear where you're going. Yeah. Also, I found Iron Brew in the supermarket. Sugar-free Iron Brew. I was joking about this when playing Pepsi Man. I was saying they should make a sequel to Pepsi Man, Iron Brew Man. Finally, I managed to find Iron Brew. Delicious rust. Rusty metallic. Iron Brew. Vegas hotels go for 12 to 14. Yeah. Well, in places like Hong Kong and Malaysia, I think they do both. So that because of the American tourists and because of the Chinese tourists. So it's like... but at least they... Well, I thought that's not just a Vegas thing. I thought that's all of America. I thought it's very common throughout America for hotels to skip floor number 13. Is it not? I thought that was just like an American thing, not a Vegas thing. Alright, let's have a look at this problem then. So yesterday's was pretty tough. I would say yesterday's was probably technically the hardest problem because it needed a specific algorithmic paradigm, which I don't think you could easily come up with from first principles. Or at least if you're a mathematician, you probably could, but you would still need to memorize, but yeah. So, today, what do we think? Looks like it's another 2D map something or other. Oh, patterns. Yikes, okay. There's all sorts of horrible things that we can do with patterns. Alright. Point of incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. So we've left Metal Island, we're now on Lava Island. Though it could be more common than I remember. It's been like 15 years since I've been in a building that's more like three stories. Yeah, that's the thing in London. Like all the buildings I ever went in, well, apart from the office buildings, were only a couple of floors. So it's like even here in Thailand, it's weird. So having so many tall buildings. There's just one problem. You don't see any lava. You do see a lot of ash and igneous rock. There are even what look like grey mountains scattered around. After a while, you make your way to a nearby cluster of mountains, only to discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction? As you move through the Valley of Mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. Okay, so we're in essentially a hall of mirrors. What was that James Bond film where James Bond walks through the Hall of Mirrors? It was Dr. No, wasn't it? Like the first film? Don't know why I randomly thought of that. So we got ash and rocks. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. Okay. To find the reflection in each pattern, you need to find the perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. In the first pattern, so what do they mean by pattern? A row? No. They mean a row or column, essentially. In the first pattern, the reflection is across a vertical line between two columns. Oh no, they mean the pattern is the whole grid. I see. And it's saying this grid is a reflection in this column here. Interesting. Fine. This one matches a horizontal pattern, sure. Okay. So, yeah, I get the example. To summarize your pattern notes, did we not have a Wikipedia link this time? We didn't have a Wikipedia link, or maybe it'll come in part 2. So, to summarize your pattern notes, add up the number of columns to the left of each vertical line of reflection. So for each vertical line we find, we count the number of columns to the left. Okay, so we're basically counting how far in it is. Basically we're adding the column numbers. To that also add 100 multiplied by the number of rows above each horizontal line. Okay. So it's just kind of like an encoding. So there's space separated between separate patterns, okay. And I assume there's a unique line of reflection. Okay, interesting. Don't need any clever algorithms for this one, I think. Just try every line. But you need to... But this is easy to do in Python, easier to do in Python than most other languages. Because of string slicing, string reversing, basically all the different string methods. Which is what we're going to be using. This is good stuff, and it's 0 sugar, 0 calories. All right. So we need to. Okay, fine. So we can identify the grids. So I guess we'll process each grid, then discard it and take the next one. We don't need to store all the grids in the list of grids, unless we need that for part 2. So we'll need Alright, so grid equals empty list. Right, so if not line.strip, so it's an empty line, then reset the grid. Alright. Otherwise, well, there's no empty line at the end, is there? There is, okay. Fine. So let's do this the other way around. If line.strip grid.append line.strip continue. Alright, grid. So now we want to process this grid. So find the line of reflection. So just make a method for this. Define get line reflection. What's the best way to just call it get reflect line for a grid? Alright, how do I signify whether it's horizontal or vertical? Should I just output a letter, HV? Okay, so let's say line type line index equals get reflect line grid. All right, and then we want a total. If line type is, let's say, letter V for vertical, that's what we're going to output. If line type is V, what? Basically just total plus equal line index. That's the number of columns to the left. Elif line else total plus equals, it's going to be 100 times line index. Is that right? 100 multiplied the number of rows above. Yeah, that's right. And then finally, grid equals that, and let the garbage collector sort that out. All right, so and then we would print total. All right, it's gonna fail, isn't it? Because yeah, okay. Now we just gotta make our method for getting reflect line grid. Okay, so let's say nm equals length of grid, so it's that height and width. Or let's start with the verticals. So for j in, we'll start with the horizontals because it's kind of easier to think about. For I in range, so we can try putting a vertical at 1, not at 0, at 1. Hang on. Yeah, okay, so starting at 1 and ending at I minus 1, so up to I. Why doesn't it like that? Oh, whoops. And I mean. Hello, Diggs. Just working on problem 13. Part 1 doesn't look too difficult. We're just finding lines of reflections in these patterns. So for I in range, actually go back to doing vertical. That was actually easier. J in range, right, 1, m minus 1. Okay, so for a given vertical line, we want to check that for every row, the left part matches up to the right part. So, but if this skew, so if the line is closer to the left, then we only need to check, we need to find the minimum width first. So let's say width equals minimum of it's gonna be j m minus j, right? So if it was, if we were at m minus 1, then m minus 1 would be 1. Yeah, okay. So whatever the minimum is, that's the width of the amount we need to check is reflected. Because if one part is small and one part is big, we only need to check the small part of each, so we can discard the big side, right? If I've understood this reflection thing correctly. Looking at the example, yeah, it doesn't have to be in the perfect center. All right, so width that we're checking is that. If okay, so basically we need to check each row for I in range n. If, hang on, for this to be a reflection line, we need all the rows to match. So we need if all, and then we need, so we need to take so it's going to be, so the left string is going to be so it's going to be grid ith row, and then it's going to go from j minus width up to j, so that's exactly width j, and it ends on j. So that is the left part. Oh, we can't do equals. If you're comparing lists, you're gonna have to make it into a, oh no, these are not lists, they're strings. Yeah, they're strings. Okay, so that's fine. That's a string. So if we're saying that is equal to, and then the right-hand side will be this. However, we need to reverse. Yeah, reverse this. Okay, this is tricky to think about, but I think that's it. If all for I in range n return vertical J. Okay. I'm just thinking maybe what I don't want to, okay, the ugly bit though is the horizontal bit. What if we just transpose the grid now? So let's define the transpose method. All right, I've got an idea. A better way to do this. Define transpose grid. So you return, so it's going to be grid hang on. Okay, so one column, we need to describe a column. That'll be grid I j for I in range length grid. That's one column. Join it up. Grid for j in range length grid 0. Okay, that is a horrible line to read. Okay. Let's check this works then. Alright, I don't like this approach anymore. Let's change this. Print for line in grid, print dot join line. Just let's see what it looks like. All right. Okay. Print new line, and then for line in transpose grid, all right, let's have a look. Just check that. Okay, so that's, we need to print more of a space here. Is that one? Oh, that's what it looks like. It's a very elongated. Fine, that's fine then. Let's just check the first part. So it's 3 dots, then a hash. And here it's 3 dots downwards, then a hash. 3 hashes. 3 hashes. Yeah, that looks right. Okay. So I think the transpose is right, even though that's horribly written. Get vert reflect line for a grid. All right. Return J. And then if we get here, return none. All right. So now we go here. we say L equals get the reflect line of grid. So if it finds one, if L is not none, then total plus equal L. Else, we have to do K equals get vert reflect line transpose grid. So that's basically doing the horizontal thing, but it's working on the transpose. So, and that is not going to be none. So total plus equal 100 times K. We're assuming that will always succeed. Okay, and then reset the grid, print total. Is that it? Let's try it then. None. We got a none for K. That's not good, is it? Get vert reflect line. Okay, I don't like this line here, but so let's check if this makes sense. So we're trying each possible vertical line. So for given vertical line, the width we're going to check is either the left or the right hand part, whichever's smaller. Okay, that's fine. So we're going to go from J minus width to J. Oh, this should be J plus width. All right, try again. There we go. 28713. 28713. Not correct. Too low. Well, we got a number. That's a good start, I guess. Tal? What the heck is Tal? Did I just make that mistake now? Tal? Oh, no, it was just scrolled. Alright, doesn't like this. Alright, fine. So... Alright then, try the examples, as always. Wait, 28713, is there a proper... I don't know if it's counting this last line. Add a space there. Now try. I'm not sure if it's cutting out the white space, is it? 29213 because I added that extra line. If I add a few more lines, it's not going to mess things up, is it? List index out of range. It should be skipping lines. Hang on. What's going on here? This should be skipping empty lines. If line.strip grid. So line.strip should be an empty string. For each of these lines, so it shouldn't oh, but it's trying to do this. Okay. Just I think whenever I save this, it's getting rid of that white space. 28713. Damn it, why does... ID thinks it knows better than me. We should write this in a smarter way then. Well, okay, before I do anything, let me check if that's the problem. So if I add 2 lines here, 29213, it's claiming is the answer now. So it was missing this last grid because nothing was triggering it because it's not counting that last line. All right, 29213, is that the answer? Oh, sorry, I was still looking at the browser. All right, so that's correct. So the problem was, it's just the way I'm handling these lines. Okay, so the input comes like that, and it doesn't count that last line. For line in f read lines, but I would have thought it would. It's an empty line, but it's still a line. It should just be an empty string, shouldn't it? Or is that end of file? So to force it, we can add an extra line, but I don't like having to change my input. So what do we do instead? Okay, here's a hack. Plus, wait, is f.readlines as an iterable? Okay, this is a hack, a real hack. There, it's as if I edited the input file. Will that work? There we go. Alright, that's part 1 done. You resume walking through the Valley of Mirrors and smack, run directly into one. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one dot or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. If the top left hash were dots, so you change one of these, we'd have a different horizontal line of reflection. Oh man. Fine. Wait, is this not just a case of just try every character? Doesn't look hard, but we just need to write a bit more. Alright, so yeah, basically we need to smudge it by flipping one of the characters. So let's tie this up. Define get score grid. Just take this logic and put it there. L equals get vert reflect line grid. If L is not none, return L. Total plus K equals get vert reflect line transpose grid. Return 100. Okay, we can just move that. Alright, so that just gets the score. So this we don't need to do, we can just do total 1 plus equals score grid. Get score. Check we've got the same. Okay, 29213. And now is this not just okay? It's pretty straightforward. If I've got that method now, generic get score for a grid, I can now just try a bunch of different grids. So but some smudges will keep the same reflection line. So we need to choose a smudge that actually breaks the current reflection, right? So AC up. Okay, it's not quite as obvious as I thought, but it's doable. Problem is, some of the smudges will result in the reflection line staying the same as before, but one will result in a change. Now, because none of these are more than 100, I think we could just take the score. So just keep trying characters until we find one with a different score. Like, he could trick us by throwing in a grid of more than 100. But I don't think that's going to happen. It doesn't look like any of the grids are that big. So we can just we can do this. For I in range length grid for j in range length grid 0 try flipping grid ij. Alright, so wait, okay, so grid I equals grid up to the jth element plus, so we want dot if grid I j is hash, else hash, so that's just flipping, plus grid j plus 1 onwards. If grid was a list, I could try flipping it. Score 2 equals get score grid if score 2 is different, break if score 2 is not equal to score 1, break out of that one as well. Alright, and then total 2 plus equals score 2. Print total 2. Wait, there's one thing missing here. Just flip it back. Alright, let's try running that. Can only concatenate list, not string to list. So, grid. So that's a string. That's a string, and that's a string. Can you not do that? All right, whatever. Just make grid a list. I don't know what is wrong here. Should I just remove these brackets or something? All right, we'll make it a list of lists because we do want to be able to mutate it anyway. Grid and list Windows strip. Now we need to change a bunch of things. So flipping is now super easy. Grid I j equals dot else hash. Okay, and then just do that. But we've also probably broken this thing. So here, if all, so that is now a list. You can't compare lists like that. You're gonna have to do tuple, convert it to tuple. Those can be compared. Otherwise, it's comparing the memory location. It still doesn't like it. 100 times none. It's not, now it's not working. All. Tuple. Hang on, transpose. Transpose needs fixing. It's gonna be. Alright, so this is simpler actually. It's gonna be so it's gonna be grid. Grid IJ There we go. Oh, it's still not working. Hang on. So it's going to be grid IJ for IM range. It's going to be, that describes one column. So it's going to be that column as a row for each column value. Yeah, so that should be the transpose, right? Unsupported operand type, int and none type. Get vert reflect line is none for the transpose. Hang on. No, that looks right. I have to check transpose again now. Let me just... I'll just take a simple example here. So... Alright, so it's score 2 that's failing, it seems. So... Score 2... Ah! It might be none. Oh. Ah, interesting. Okay, so... We have to actually return none. Okay, so because now that we're fixing these smudges, there might be invalid grids. So in that case, we want none. All right, so if okay, first of all, we can put this here so we don't actually need to flip back. If score 2 is not none and score 2 is not equal to score 1. Alright. In fact, we don't need to check is not none. It would do that anyway. Int and none type, what's going on? Total plus equals score 2. If it's none. Oh, no, we do need to. Damn it. Is not none and score 2 is not equal to score 1. Break. If Total plus equals score 2. What? Score 2 is still none? Score 2 equals get score grid. Sometimes it'll be none. When we find one that's not none, print it. We don't. Total 2 plus equals score 2. So it should. It's not. So it's just not finding anything. If we use an example for which it's actually possible, maybe we should be using one of the later ones. Yeah, it's the same one. Total plus equals score 2. So score 2 is always none. It's never finding... Oh my god. Print all the values of score 2 then. It's either 5 or none. And for so hang on, what do they mean by smudge? No, it's just a flip. It doesn't matter, it's not one way. Okay. So we're saying the score should be 300 actually, but we're getting 5. 5 was the case for... Yeah. 5 is the original one, so we're not finding this horizontal line of reflection anymore. So if we change the first character, get score grid, then it should... Ugh. With all these changes, I better check that part 1 is still working. Might have broken part 1, that could be the problem. Just comment that out. want a none type. What the heck? Nope, it's broken. What have I done? The only thing I've changed is I've switched from strings to lists so that it's mutable. It doesn't like that, does it? I don't think my transpose is right. Should it be J? It should... No, wait. Grid. IJ. Should it be JI? Hang on. No. J, okay, so this, what the rows are supposed to be what the old columns were. So one row of the transpose is grid I J I in range. That's right. That's one column. And we're treating that as a row in this transpose. For J in range length. I'm gonna have to test this now. Oh my god. Why is it so hard to transpose a grid? Hang on, I gotta think this through again. The identity would be this, but we're just doing grid IJ for J in range M. And then that whole thing for I in range N. So you switch I and J. You could switch I and J here as well. So instead of I in N, it would be J in M, and here it would be I in N. So I've done that. And then that should give you a new grid, and these are new elements, so that's not gonna pass by reference or anything. If all tuple grid I J minus with J. Man, maybe, but it worked when it was strings. All right, just test the transpose. Or row in grid. Print dot join row. Okay. Print and then for row in transpose grid, do the same. All right, try that. What's wrong? List index out of range. My transpose method is just broken then. Grid IJ I in range N J in where range M. Hello, Ku. Yeah, AOC has been good. Yesterday's was a tough problem. Today's is not tough, but I'm just stuck with matrix indices. Can't even transpose a matrix. Grid IJ for J in range. That's width and that's height. What's wrong with this? Is that not how you transpose a grid? Grid IJ. Surely it's more than just transposition. What do you mean? This method is just transposition. The whole problem should be more than that. Yeah, but the problem I'm having right now is that I'm not and that my transpose method is failing. I can't get my head around these indices. For some reason that method right there, it doesn't like it. Should it be JI? No, I've been down this path before. It's... Hang on, so that is one row of the new grid. And we're saying that is whatever the column was in the old grid. So it's grid IJ for I in range N, which was the height. So that should be the column. I don't see anything wrong with this. List index out of range, J. Start with the most simple example. Okay, did it transpose? Yeah, it did. Yeah, that's a transpose. Oh, I know why that was failing. Okay, fine. It's because I've commented all this stuff out, but I needed the one line grid equals. Okay. At the end of there. Okay, same result. Okay, so that transpose looks okay. So if I try to compute the score... arg 5. It's correct. And now just make sure that the whole problem is we're still working for part 1. 29213. Yes, okay. So we're working for part 1 again. Now try this part 2 code. Here we go again. So okay. Let's go back to the basic example. That. Okay, so part 1 is 5, okay. So we don't want to print this anymore. Okay, so for part 1 it's 5. Alright, for part 2, we are trying to change an element of the grid. So ij. So we take grid ij and change it. So normally it's a hash in the first, in the top left corner. So if we change it to dot and then run the score, according to the example, we're supposed to get a different score, but instead we don't get any score. It can't find any line of reflection. So grid ij, so that's is mutable now, so we should be allowed to do that. Then we try to find the score. And then flip back. Should be as it was to begin with. Is it? Good to append lists. Yeah, it's a list, so we can change elements. It's fine. It doesn't matter for score because score just treats it as immutable. So. Score 2 is not none, and score 2 is not equal to. Alright, then we're gonna have to first make sure we're actually getting the right list, the right grid. Let's write a print grid method. So we can join the row. Let's just print this at the beginning and end, just to make sure. Alright, so we've got... So at the point at which we've changed the character, let's print the new grid, see what it looks like. Maybe something's gone horribly wrong. What's with all the prints? Oh. Okay. Just break out of everything. Okay. That's what it looks like with the bit flipped. So that's a dot. It used to look like that and now it looks like that. Has anything else changed? No. Looks right. So now, with that, there should be a... It should be able to find a vertical line. So, why doesn't it? Wait, no. What should it be finding? No, not vertical line. It should be finding... Oh, maybe I've misunderstood the description. A new horizontal line of reflection. So the original example they had a line of reflection in column index 5. Now, changing that hash to a dot shouldn't break that. That still holds. So what they're saying is there could be more than one line of reflection now. We need to find both. Oh, for goodness sake. Well, yeah, okay, to be fair, they didn't say there'd be a unique line for part 2. They did say there'd be a unique line of reflection for part 1. But for part 2, it says the old reflection line won't necessarily continue being valid after the smudge is fixed. Fuck. So, okay. We need to output both lines. That's the problem then. Okay. That can be done. We just have to get scores. So get all the scores. Scores equals that. L equals if L is not none. Hang on. Yeah. L equals, so, okay, so we're actually gonna have to return all possible lines. Lines equals that, empty list. And whenever we find something here, lines.append j, return lines. All right. So now this just returns a bunch of lines. Get scores. Scores is that. L equals okay, so now we do for L in get reflect line grid scores dot append L, and then for K in that scores dot append that. So we're just accumulating all the possible scores. I think there can only be 2 at most. All right. So okay, local variables not used. What? Oh, whoops. Okay. And now for part 1, score 1 equals get scores for grid, just the first element, because there'll be only 1. Okay. Let's just make sure that didn't break part 1 now. Run 5. Okay. Just quickly test the full example. 29213. Okay. Okay. So that's fine. Now for this, so scores equals get scores of this grid. All right. Or just do for, let's say, I don't know, X in get scores grid. If X is not equal to score 1, so we're trying to find a new score that doesn't match whatever we had before, because it's sometimes score 1 will appear here. That's the catch here. Score 2 equals score 1. Break. Oh, we have to do all sorts of breaks here. That's okay. It would be better if I did this as a method. Yeah, a method. It would have been better. Okay. If score 2 is not none, break. If score 2 is not none, break. Take out these extra breaks. All right. Let's see what we get. 5, 5. Why did I say it equals score 1? No, I want X. 300, 300. Is that right? So they said, for this example, rows 3 times by 100 for the score, 300. Correct. Okay. Let's try the whole thing then. I think it will work. Why am I printing so much? Okay, well anyway, 37453. 37453. correct. It's not a hard problem. It's just and it's made easier with Python, because Python you can just do string trickery, but just messed up my matrix indices, I's and J's. Alright, well that's it. That took me an hour and a half. That's way longer than it should have been. This is not a hard problem. Let's have a look at the old leaderboard. We've got, who's this new entrant? Alright. Oh, I see Umaro has done problem 12. I thought he didn't want to do problem 12. He was scared of it when he saw me doing it. Alright, well, good. 12 part 2 is a tough one. Yeah, look, that's the lowest percentage of part 2 completions yet compared to part 1. It's almost 50%. And the fastest was 6 minutes 06. Yeah, well, it's not actually that hard. And I'm sure top coders have all kinds of matrix methods up their sleeves. These are just lots of standard methods: transpose, reflections. There's a slight cheat here in my code. It's assuming the grid is never more than height 100, because then the scores won't be unique. It won't uniquely define the horizontal index and the vertical index, because it's vertical index plus 100 times horizontal index. So from that you could see which one's the vertical and which one's horizontal. But if you had really long grids, that would no longer be true. And then I'd have to label these. Well, it actually doesn't matter. Well, for part 1 it doesn't matter. Part 2, it really depends on what they meant by the question. Because if there's a different line, but it happens to give the same score because it's so far along in the vertical that it actually adds up to almost being 100. Yeah, it's unrealistic. It's not going to happen in these inputs. It's clear enough. Okay, I'm done. Is there any minor cleanup I want to do? I mean, normally I leave the code exactly as is, other than like removing some prints and stuff before I upload it to like GitHub, or don't need to print any grids. I think there's enough comments already that makes the confusing bits clear. Try flipping grid, no log flip back, yeah. That's a bit of a mouthful, but it does what it's supposed to, so. Alright, then I'm done. Anything more to look at here? Stats, leaderboard, no. Alright. That was nice early. Well, I started about an hour late, but that's still the earliest I've completed one of these because I normally start a few hours late from the problem release time. Oh, it looks like... What was it? Okay, so it was Snow Island. Island. Desert Island. Metal Island. Or Gear Island? I think they referred to it as Gear Island and Metal Island at 2 different occasions. Lava Island. There's not enough room for any more islands. But where are we headed anyway? I forget. This looks like it'll be the final island. No, wait, what am I saying? There's still 10 more, 11 more days, so there's gonna be plenty more islands, maybe another 5. Okay. Alright, thanks for watching. See you tomorrow.